Good afternoon, everyone. Today, I would like to talk about how an abstract concept from linear algebra, orthogonal projection, plays as a crucial role in the physics technology we use almost every day. Noise cancelling headphones. The the first claim, the linear algebra often feels distant from real life. We deal with vectors, matrices, and subsets, usually on paper or in exam. However, my goal today is to show that loose mathematical tools are not just theoretical. In fact, they are actively working behind the scenes to make our daily lives quiet and more comfortable. Everyday motivation has us begin with a simple everyday problems. In modern life, we are constantly surrounded by wanting noise, traffic, sound, conversation in public space, and engine noise on the public transportation, or background noise in traffic. And sound reduce our ability to concentrate and perspective fatigue over long periods of time. Noise cancelling headphones are designed to address this problem. When we put them on, surrounding noise significantly reduce, allowing us to focus on music or study or simply enjoy silence. But how does a pair of headphones achieve this? The answer lies in mathematics. Well, this is linear algebra problems. From a mathematical perspective, sound is not mysterious. Some signals can be recorded simple and represent as a vector in high dimension space. Each component of vector corresponds to the sound amplitude and the previous moment in time. When microphone captures sound, it does not distinguish between what we want to hear and what we want not to hear. Instead, it records a combined signal. Mathematically, we can describe it as the recording signal is sum of the design sound and environment noise. In other words, both music and noise coexist in the same vector space. This is exactly where linear algebra becomes useful. The core mathematics concept behind the noise cancellation is orthogonal orthogonal projection, which we study in week 5 and week 6 in this course. Orthogonal projection allows us to project a vector on the space intuitively. This means we can extract the component of signal that lies a particular direction of some subspace, or ignoring the rest. In the extent of the noise cancellation headphone, we assume that environment noise occupy a specific subspace, often called a noise subspace. This assumption is reasonable because many types of noise, such as ambient sound or air conditioner noise, are respective in structure. By projecting the recording sound signal into the noise subspace, the system can estimate the noise component mathematically. And let we see the geometric institution. To to build some genom, geometric institution, image some signal uh, as a rod in space. The desired audio signal such as music, speech point in one direction. A noise signal points in a different direction. Those directions are not necessarily perpendicular, but they are distinct. Orthogonal projection allows us to find a shadow in the total signal and noise digression. This shadow represents the point of the sound that most closely aligned with noise. Once its noise component is identified, it can be subtracted from original signal. Mathematics perspective. And from a mathematics Same point, orthogonal production has a very important property. It provides the least square optional approximation. This means that when we project the signal onto noise space, the difference between the original signal and the projected noise is minimized in terms of square error. In simple terms, this approach removes as such noise as possible while causing minimal disruption to desired sound. This is why noise cancelling headphones do not simply mute everything. Instead, they cleverly remove noise while preserving the quality of music or speech. And how noise cancelling headphone works. In practice, noise cancelling headphone use microphone to capture the ambient noise in real time. The system The system then estimate the noise component using projection-based method and generate the anti-noise signal. The anti-noise signals has the same magnitude but opposite phase as the noise. When played through the headphones interface disrupted with the incoming noise, effectively can cancel it out. Also, as the actual impediment involves signal processing and adaptive algorithms. The fundamental idea is still rooted in the orthogonal projection and vector discombination. Why orthogonality matters? If orthogonality is essential in a process, when two components are orthogonal, they are not interfaced with each other. By separating noise and design signal approximately orthogonal components, this system ensures that removing noise does not unti- unintentionally remove important audio information. Explain why high quality noise cancel headphone feels natural to use. The mathematics general guarantees stability and minimal disruption. Connection to the course topic, and the implicit example is not isolated with the one chapter of course. Chapters define where sound signal life. And also neural projection determine how the signal are separate metrics bring light in how much noise can be realistic be removed. Together, this concepts from a unfailed framework. Noise cancellation is therefore an excellent example of different linear algebra connecting and work factor in a real world applications. While this is matter in daily life, this learning practice of the technology is very practical. Noise cancellation headphone improve relation study, reduce figure during a long commute, and protect hearing by reducing the need of high value labels. All those benefits are made possible by mathematical principles we study in class. And big example and in big picture and conclusion. The conclusion concludes to conclude the author's production is not just an abstract mathematical concept. It is a powerful tool to transform raw data into useful information. And in the case of noise cancelling headphone, linear algebra literally turns mathematics into silence. This example demonstrates that while what we learn in the course has great and meaningful application in everyday life. Understanding linear algebra is not only about physics, it is about understanding the invisible system that shape modern technology. Thank you for your attention.